So I'll give you a quick recap on the previous session, what we have discussed. So we discussed about SAP HANA, the basic architecture of SAP HANA, and we also discussed why HANA is faster than the traditional relational database systems. How it is different from relational database systems. So HANA database stores the data in RAM level, the primary memory, so that data access from the RAM is faster than accessing data from disk, right? So that's why HANA provides better performance in terms of data selection because it is directly selecting from RAM. So also we discussed what is RAM. RAM it is a temporary memory, right? It's not a permanent memory. It is a temporary memory, right? So if there is any system failure happens, what about the data? Are we going to lose the data?
Yes, sir.
Since the data is stored in RAM level? No,
Yes, sir, we will lose it.
no. Yeah, we'll lose it
But we'll
temporarily
have
from
it
the
in the
RAM.
disk.
Yeah, we'll have it in the disk. So we can reload the data to the RAM level again. Okay, whenever the system is restored or issue is fixed, we can load the data from the disk into RAM level, right? Again. So and there is one more criteria you need to observe. See, what is the RAM we are using in our laptops now? Around 16 GB or 24 GB, right? Yes or no?
Yes,
Around,
sir.
yes.
Yeah.
So yeah, that is to store our personal data like simple files and all these things, right? Even sometimes system used to hang when we are processing some large applications in our personal laptops. But when you take one organization, right? When you take one organization, they are going to process a huge amount of data, right? The size of the RAM is really important here, right? So to perform like to provide the better performance. For example, one organization is using 1 TB of RAM, 1 terabyte RAM, right? So in the disk in disk there might be huge amount of data, maybe 10 terabytes of data, right? So can we accommodate all the data available in disk into this RAM level? Let's assume it as 1 TB. Can we accommodate all the business data into RAM level so that we can access data from the RAM? No, right? Because RAM size is only 1 terabytes. There is some limitation, right? In the RAM size. RAM, like RAM is expensive, I think, than hard disk, right? So depends on the availability of RAM. What we need to do? We need to load the data. We don't need, if you don't need all the data into the RAM level, the data which you are using very frequently will be loaded to RAM. Okay, so we are not going to load all the data of disk into RAM level if there is any limitation of the RAM. Okay, the RAM size, whatever the business data we are accessing very frequently will be loaded to the RAM level. Okay, and even we can manually load whatever the table data we want to be available in RAM. Depends on our requirement. Okay, the other advantage of HANA database is it stores data in the column store tables. How normal RDBMS stores the data in database? For example, if you take any record, let's take this record. I'll give you some basic details. We'll discuss in detail about this column store data later. In traditional RDBMS, how data will be saved in the disk? Let's assume some Chennai. So in traditional RDBMS, the data will be saved like this in a sequential manner, not exactly like this, but one after one, one after the record, one after the one, it will save in the disk. But how column store data in HANA stores the data? So for each column, HANA generates one table for each column. So it will be data will be maintained like this. So it will maintain some index to identify the data. It will maintain some index number, and it E102. And for one more column name, again it will maintain one more column store table. Can you tell me when we are selecting data from database table, are we going to select all the columns data? Are we going to select all the columns data or only selected columns? Can you hear me?
Only selected columns, sir.
Only selected columns, right? So when the data is maintained in column store tables, every time the system or the application program doesn't need to search for the entire record. So whatever the columns we are selecting, it can just search for those columns in the column store tables. So that is one advantage of maintaining column store tables. So whatever the columns we are selecting, it will just go and pick from those columns. It doesn't need to search the entire record for those individual column values. And there is one more advantage of maintaining column store tables. Let me show you. We can save lot of system memory or disk memory by maintaining the data in column store tables. How that will happen? Let me show. So it provides a better data compression. So data compression is another advantage of using HANA database. This is column store table for employee name. Let's create one more column store table. So how many entries are maintained in this city column store table? Column store table for city, how many entries we maintain? Only two, right? Only two values. So it is not maintaining the repeated entries. Please observe in column store data, it is not maintaining the repeated entry, right? It will maintain only unique values, and all these values will be connected with the key value with some index. Okay. So database system will take care of that indexing. So which city value is connected with which employee column and which employee names column store table. It will maintain, somehow it will maintain that index. We'll see like when we are discussing on HANA in detail. So it will each column store table is connected with each other with some index. Okay, but here the city is repeating, but in the column store table we are not maintaining the repeated values, right? For example, there are 1,000 employees in the company whose city is same. All 10,000 employee record city is same. How many times we need to maintain that city in traditional RDBMS table? You observe here how many times we need to
1000 times.
maintain?
1000 times.
Every time we need to repeat the same value, right? In our traditional RDBMS entries, we need to repeat the same city for all the records, right? It is, so value is same, but we are repeating it again and again. It is taking, it is occupying, it is going to occupy some memory, right, in database. So when the data is maintained in column store, it won't maintain multiple times. In the column store table for the city, it will maintain only once if the city is same, right? So that it's going to save a lot of database memory, right? Whatever the database memory it is occupying, where we are going to save it, right? So the data, for example, if it takes 10 MB to store some data in a traditional RDBMS, like any Oracle or MS SQL server or whatever, right? It will take only in KBs in a HANA database. So it is providing better data compression. We are able to save a lot of memory by using column store tables, because it is not maintaining the repeated entries, repeated column values. It will only maintain unique column values, and these column values will be uh, connected with the remaining column store tables with some index number, so that it doesn't need to maintain the same value again and again, since we separated each column into a separate column store table. Okay, the read performance is faster in column store tables, right? And what is the other advantage of using column store tables? Data compression. Data compression is the other advantage of using column store tables. We can save a lot of database memory by using column store tables. Okay, and we discussed about CDS views. What is CDS view? Core data service. Core data service. So CDS view is a code push down technique. Please observe this. Please remember this term. Code push down. Code push down. What do we do using CDS views or AMDPs? This ABAP and HANA concepts. What we are going to do? Code push down. What do you mean by code push down? Executing the complex data selections in HANA DB level instead of executing in application layer, right? So instead of executing in application layer level, what we are doing, by using CDS views, we are executing that complex data selection in HANA database level. Why it is faster in HANA DB level?
Because it stores data in RAM level.
Yeah, because it stores the data in column store tables, and HANA provides multi-core parallel processing. Multi-core parallel processing. What do you mean by multi-core parallel processing? Each core represents one CPU. Each core represents one CPU memory in HANA architecture. So depends on the number of cores you have in your HANA layer. It will divide task into different cores, different parallel processings, and each core will process each part of the data processing, and it will combine the results. For example, if you have 10 CPU cores in your HANA architecture, so it will parallelly that the like whatever the data execution or data selection will be parallelly executed in all these 10 cores, right? So that's why the performance is very faster, and the other advantage is it will select the data from RAM level. Can we select all the business data from the RAM level? Any business data from the RAM level? Whatever the data, whatever the transactions available in SAP ERP, can we select everything from the RAM level? No, right? As we discussed earlier, there is some limitation of memory, right? So depends on the memory size. So we are going to load whatever the frequently used business data or whatever the data we are frequently using, we loaded that data into RAM level. So we can select only such data, that kind of data from the RAM. Okay. In case if you want to maintain any data in the RAM level, you can load it into the RAM level from the disk to RAM level. Okay. So even though we have a lot of data in the database, we don't select all the data every time, right? Most frequently, we used to access only specific application data. So that data would be maintained in the RAM level. Okay. So what is code push down? Code push down means executing data selection logic in HANA database level instead of executing in our application layer level, right? So when you write OpenSQL statement, that is normal select statement, where it will execute,
In the
or if you
application
write
layer.
any loop, for example, if you write any loop statement, where it will execute, the application layer level. Why we use loop statement? To process the internal table data, right? To process the internal table data, right? By looping the internal table data, we apply some calculations and we build some final output. Yes or no?
Yes, sir.
But if we can push the calculations and data selections and whatever the processing we are doing on internal table, if we can push that entire execution to HANA database, since HANA has multi-core parallel processing and in-memory database and column store tables, so we can do it much faster than the application layer level, right? Yes or no?
Yes, sir.
So by using CDS views, we are going to push all the programs what we are creating in application layer level, right? That complex business logic, including loops, conditions, everything, we push as much as possible to the HANA database level by using which one? CDS view. In CDS view,
Yes.
we build that complex business logics so that we can push all the complex business calculation to HANA database layer. And in the program level, what do we get in the program level? The final output. The final output we are going to select from the CDS view. After calculating after applying all the calculations and data processing, we are going to get one final output into our program, right? By using that select statement. Yesterday, in the previous session, we implemented a select statement, right? So there we are going to get the final output actually. We, uh, you mean like yesterday also we executed the select statement, But further we don't need any loops on it, right? So we are going to get that final output after processing all the data, right? That all the processing data calculations where we applied in the CDS view level. Okay, since we are in the beginning stage, we have observed only a basic CDS view. Going forward, we can see the complex business logics using case statements, different string operations. We can apply functions, right? Everything we can see. So what do you mean by code push down?
It will execute the complex. It will execute the data in the HANA database.
Yeah, whatever the data processing logic we apply, we build that data processing logic in the CDS views, right? And only we get the result data into our program and display the output. Okay. For example, it will take, for example, if it takes 1 minute to execute the program by using OpenSQL statements and loops and read statements, and if we can push it to HANA database layer level using CDS view, it might take only nanoseconds, right? Since these are basic select statement, you cannot observe any difference. But when we are trying to implement complex business processings using multiple loop statements, multiple read statements, so you can observe the difference. We'll see how to check that difference and how to compare the execution time and everything. Okay, in previous session, in further sessions. Is everyone clear on this code push down and column store tables?
Okay.
So HANA contains both column store and row store tables. Actually, it contains both. You can observe that in data dictionary when you are creating tables. In technical settings, you can observe DB specific properties. It shows both the column store table and row store table. Column store tables are optimized for read. So it will provide very efficient read performance when we are trying to read by using some data selections. So it provides very better efficiency, the column store tables. Okay. It is traditional row store table. How data will be stored in a row store. It's a traditional row store table. Anyway, in the one more session, I'll take in detailed class on the column store tables. So is everyone clear why we are creating CDS views instead of writing normal OpenSQL select statements? Is everyone clear on that?
Yes, sir.
Yes,
For
sir.
code push down, to achieve the code push down, to improve the performance of the data selection logic or data processing logics. Okay, code push down means we
I,
are
I
yeah,
I have one question.
yes.
So instead of CDS view, so is there a regular view also, or only CDS view?
See, in regular view, we can create in the data dictionary itself, ABAP data dictionary itself. That is just
Okay.
we are joining multiple tables, just like how we are doing it in the select statement, right?
Mm.
So in that view, we can just join using inner join. Multiple tables we can join using inner join, only inner join. Okay, it's not
Okay.
going to provide any performance. If you take if in the performance standpoint, it's not going to provide any additional advantage, right? It will since
Okay.
even that join also executes in the application level. It's not going to provide
Okay.
you any advantage of the performance, right? But when
But
we use
that is
CDS view,
possible. Like the regular view also we can create. Okay.
yes, we can create. I'll show you. Like once we complete, we
Okay.
have multiple types of views, like four different types of views. So we'll go through that. Okay.
Okay.
Even when you create a CDS view, it's going to generate one data dictionary view. We are providing a name, right? Data dictionary view name.
Yeah.
So it's going to generate one data dictionary view. But that's not by if you use the data dictionary view, like like that's there is no difference like with normal OpenSQL statements or the database view, right? Performance wise,
Okay. Okay.
because both will execute in the application layer level, right? But when we use CDS view, you can replace all the complex loops, right? And data processing and everything. And we can push everything into CDS view. We can keep all the data, that logic into CDS view, and we can get only the final output into our program level. But if you take data dictionary view, if you create normal data dictionary view, we cannot apply all these functions, conditions, right? And we cannot use alias names. There are many advantages of using CDS views. We cannot achieve all of them in normal data dictionary view. It is a simple join between multiple tables,
Okay.
okay, by using inner join. So as I shown you, when you HANA Studio is not only the way we can access ABAP on HANA or ABAP objects or ABAP projects. You can also use Eclipse editor. Install the Eclipse editor, and by default, can you create ABAP projects when you first installed it? No, first you need to add the tools here. Go to help, install new softwares, and in ABAP development tools, go to this URL tools.hana.ondemand.com, or you can simply search it in Google for SAP development tools for Eclipse. SAP development tools for Eclipse. So here you can go to SAP development tools. Depends on your Eclipse edition. Depends on your Eclipse edition. It will provide different URLs. For Eclipse Oxygen editor, you have this URL. For Eclipse 2023 version 09, you have this editor. Okay, depends on your installation. You need to use this URL. Copy this URL. I am taking this. First time you need to add this URL here and press enter. It will show all the development tools here. Whatever the development tools we need to install. For example, we need ABAP development tools, right? To work on ABAP applications. So select this checkbox and click on next, right? So it will install ABAP development tools. Since the tools are already available, we don't need to install again. I don't want to, let me cancel this. Okay. So anyway, the tools are already available, so that you don't need to install again, right? In the our HANA Studio environment. But if the tools are not available, first install all these tools. Then only you can create a ABAP project, right? For SAP BW development, you need to install separate tools, SAP BW tools. For HANA database development, you need to add native HANA development tools before going to work on this. Okay. I'm just cancelling this since the tools are already available. So in the last session, we have observed how to create the table, right? What is the syntax to create the table in HANA Studio or in Eclipse environment? By using define table, right? By using define table and the table name, and provide the fields here. Whatever the key fields you want to maintain, maintain it as a key field. How can you maintain the technical settings?
Annotations.
Annotations. You can use these annotations. This is delivery and maintenance allowed. The first tab, whatever we observed, delivery maintenance allowed. This is data class A, right? We have more annotations. We can observe that later, right? So SAP is like pushing the customers or its clients to this Eclipse based environments rather than GUI based applications. It is trying to push the users to use Eclipse based environment. Okay, so since it is adopting more cloud features, cloud environment, right? But still, like Usually we use GUI only in most of the projects. But when we need to work on ABAP and HANA applications like CDS views, there is no other way. We have to use HANA Studio. Okay. So please try to create tables using this syntax as well, define table syntax as well, because it's very simple, right? There is no complexity here. Only thing is we need to explore more annotations, different annotations we need to explore. I think it will give it's not providing any list. No, it's not providing any list here, but somewhere we can check that list. We'll see that later. Let me close all these tabs. So this is the CDS view, what we have created in the previous class, right? By using a single table, we created a simple CDS view. Okay, you can maintain all the fields here, whatever the fields you want to select. So what is the navigation to create the CDS view? Go to package, whatever the package you want to use to for the CDS view development.
Core data services.
And here you can find core data services,
Right
right?
click on that.
So here we are selecting only required fields, right? Only selected fields, right? How can we select all the fields? Do we need to maintain all the fields? For example, if there are 100 fields in the table, if you want to select all the 100 fields, do we need to maintain all the fields here? No, simply
Uh,
use, I think we can simply use star. If you use star, what will happen?
It will
Like
select
this.
all the fields
It
from the
will
table.
select all the fields, right? Let me execute, run this, run as a web application. You can see the data preview here. So it is selecting all the fields from the table. If you simply use a star, okay, here. Now in this session we'll see how to use joins. So what are the different types of CDS views? We have different types of CDS views. CDS on single table. Second one, using joins. Third one, CDS using parameters. CDS using associations. CDS views using associations. Single, we have already created a CDS view on single table, so we can simply select data from one single table. So if you talk about the performance, so there is no like much use of writing a simple data selection in CDS views. It's not going to provide you any performance advantage. Instead of that, you can simply go with the normal open SQL statement, normal select statement in the ABAP, right? So when it makes sense, when you are joining multiple tables, many tables, and when you are applying some calculations, then only it will make some difference. It will provide you better performance, right? When you are using CDS view. So join means CDS view is using join. We can simply join multiple tables. So how, like whatever the join conditions you are using in normal select statements, you can see the same join statements to combine multiple tables and provide the outputs. CDS view using parameters. What do you mean by parameter? In normal ABAP program, it is an input option, right? So that we can select data for only that specific inputs. So in the CDS views also we have a parameter option. So where you can provide the value in the parameter and you can select only for the data. We can also use where condition, right? We have used where condition, right, in program level on the CDS view. Yes or no?
Yes, sir.
We have used where condition, right, in the CDS view. But how parameter makes difference? The where condition will filter the data in application level. Whatever the where condition we are applying on the CDS view data selection, it filters data in application level. But if you use parameters, it will filter the data in database level itself, in the HANA itself. Okay, when we use parameters. So associations, we are going to combine multiple CDS views by using association concept. So I don't want to confuse you now. First we'll see basic CDS views. Now let's create a CDS view using join. How to create a CDS view? Go to the package. In projects usually we don't use a $TMP local package. We use proper package name, right? So depends on the module or application, we are going to use that proper package name. Right click here or right click on the core data services folder, right click, new. What do we need to create? Data
Data
definition.
definition.
Data definition. Provide the CDS view name. Here also you can package change the package name whenever required. Z demo sales some name. Okay. Provide the description. You can also copy. You can also copy the existing CDS view into a new CDS view by using this referred object name. Here you can provide the existing CDS view name so that it will copy the same into the new CDS view. Next, it won't ask for the transport request because we are saving it in the local package. Next, here you can observe different options. Anyway, this is optional, right? Here you can see different options. Define view with joins. What it is saying? Define view with join, define view with parameters, define view with associations. When you select this option, what it will do? It will provide some basic syntax. Let me select define view with join. If you see here, it is automatically providing some syntax, right? Some syntax, so that you don't need to worry about whether I need to use a dot, whether I need to use dollar, whatever you need to use. It will provide some basic syntax, right? Yes or no?
Yes, sir.
CDS view with associations. For associations concept also, it will provide some basic syntax. Select define view with parameters. For parameters also, it providing some basic syntax. Define view, CDS view name with parameters. With parameters is the syntax. With parameters, parameter name and the type. Type nothing but data element. Parameter data element. Okay, it will provide that here, right? So you don't need to worry about the syntax, the basic syntax, right? Let's select a CDS view with join. Finish. Anyway, that is optional. You can build your own query without selecting this option. Yesterday we have created, right? If you see this, what are the mandatory inputs we need to provide? SQL view name, nothing but it will generate one data dictionary view. Provide the name zdemo CDS v underscore sales, some name. I think there is a length limitation. There is a length limitation for the view name. We cannot provide any name here. I'll provide like this, right? So it will generate one data dictionary view. We have a lot of other annotations here we can add. So it depends on the requirement. We need to add, we need to use a lot of annotations here. We'll see that later, all of them. Once we understand the basic CDS views. Now I am creating CDS view using join, right? So as select from data source, whenever you see data source name, what does this mean? Table name, okay? Data source nothing but table name. VBAK, VBAK by default, what type of join it is taking?
Left outer join.
Left outer join. By default it is taking left outer join. You can also change the join, okay? You can also change the join to inner join or right outer join. Joined data source name, because it is providing some help, right? For syntax help here, since we selected the CDS view type as join. What is the joined data source name? VBAP on. It is automatically changing even these tables in the joins condition on. What is the join condition? VBAK,
E,
VBELN, right?
VBLN.
VBLN, VBAP, VBELN. That's the join condition. Here what you need to maintain? Can we use star? What it is
No, sir.
saying if
There
you
are a
use
lot of
star?
data, lot of fields.
Select star and joins are not valid together. So what it is saying? You cannot select all the fields from the both tables using star. It is, we cannot select all the fields from all the tables, all of these tables. So we need to maintain the fields list, whatever the fields you want to select here. You can also use alias names instead of as A, as B. You can also use alias names instead of table names. You can also use alias names here. Okay.
Yes.
So you can represent your table with that specific alias name. And join one more table. Left outer join MAKT. Left outer join MAKT. And the join condition on. What is the join condition?
Matner. VBAP Matner and MKT Matner.
Then maintain all the fields whatever you want to select. You can see the fields, list of the fields from the table here. So you don't need to worry about insert all the elements. If you select this, what will happen? I think it will insert all the fields like this, right? I don't want all these fields. I'll select only few fields. I'll just select ER date. VBAP dot POSNR, right? Alias name is optional. This alias name is optional, right? You may or may not use this alias name. That is optional. Okay. Mains. NETWR. Value. You can use underscore in alias names. We cannot use space or anything. We are using same column multiple times, right? Are we missing anything here?
Matter, sir.
Matter is here.
Okay. Okay.
So what about this? We need to pass. We are selecting text table, right? For text tables, what is required?
Language, sir. System language.
Pass.
Pass.
You can pass like this, or you can also pass in the where condition. Where MAKT what is the syntax error? Do we need to use any escape symbols here? Okay, anyway, we'll worry about that later. I think yesterday we have already used it. Okay, we need to provide the join conditions. So check the syntax, activate it. Now we have our CDS view with join. So how can we use this CDS view? How can we use this CDS view?
Sir, by SC11, sir.
No, in program you can use a select statement to read the data from CDS view, right? Let me go to GUI and write the program. As I said, in S11 we can check that if you know the this data dictionary view name, right? So this is the CDS view, data dictionary view, it is generated. This is data definition. Data definition, nothing but what is this? CDS view name. If you double click on this, you can see. But can you edit it here? No, you
No,
can't.
sir.
You can't edit it here. You can only edit the CDS views in this Eclipse workbench. Okay. So how can you make use of the CDS views? There are multiple alternatives like how we can consume or how can we use the CDS views. One way is using this in report programs by using in select statement. That is one way. The other way is we can use this as data sources. Like if you take any other additional systems, BW systems, we can understand that we can use it as a data source, but for BW systems. Also we can generate services. Also we can generate services on CDS views. It is not simply writing select statements on CDS views. There are a lot of other advantages. There are a lot of other functionalities we can build on top of CDS views. Okay. So in these like cloud environments, since SAP is introducing more cloud environments, so it is recommended to use the CDS views and OData services concept. There is a combination what we call as RESTful ABAP programming model, where we are going to build CDS views for data selection and use services, those OData services to read the data or to create the data. So I don't want to confuse now, but yeah, these are the basics for that RESTful ABAP programming model. So let's quickly create one program. Create. So I'll just focus on calling the CDS view. You know the rest of the things, right? Parameters, validations and everything you already know. My focus is on calling the CDS view. How to call the CDS view in our program level? Do we need to use data dictionary view name or CDS view name? We need to use CDS view name, right? Select CDS view name. Sorry, select star or select individual fields, whatever. Select star from CDS view. Since we have already filtered, since we have already selecting only required fields, you don't need to worry about the fields. You can simply use a select star. Select star from CDS view into table sales. I'm not using any where condition. If sy hyphen subars equal to 0 and if okay, let's just execute this data, right? From where it is selecting this? From the CDS view selection. Okay, so it will execute this data selection logic will be executed in the HANA database layer, right? But even normal select statement also execute in HANA database layer only, right? Sorry, it executes in database only, right? Even if you write normal select statement, it needs to go into database and need to pick the data, right? But what is the difference? Like Here we can apply data processing statements in CDS view. We can apply a lot of we can replace loops whatever we are writing here in ABAP programming level by using some statements, like we have a lot of case statements, functions, and everything we can apply. So when we are start using these associations and more complex joins concept, right, then we can really understand the difference, how that CDS views are better than normal open SQL statements. Okay, instead of looping all the data in ABAP application layer level, instead of looping millions of records in the ABAP application layer level, what we do, we keep all that data processing logic in CDS view, right? So in the next session, we'll conclude on the CDS views, the basic CDS views, whatever required, using parameters and using associations. And then we'll continue with our normal ABAP rise of development objects, right? And later, once we completed this ABAP rise of developments concept, then again we start on this ABAP on HANA. Okay, because both are important. The CDS view concept is important in the recent days projects, as well as rise up concepts also important. Okay.
Yes, sir.